So we are doing chapter 10-2, and we are talking about circles and what we are going to call a tangent line. So circles and a tangent line. So here is the definition for what you need to know. You have a circle. What is the name of this circle? Circle A, we name it by the center. A tangent line is a line that touches a circle at only one point. So this is an example of a tangent line. This could be line M. Remember, we can name lines with lowercase letters. We can name it by 2 points. So this could be line BC. And I am telling you that it is tangent, which means it only intersects the circle at one point. That is the ones that we are going to be dealing with today. We are only dealing with tangent lines. What other types of lines could there be? Well, there could be a line that intersects the circle how many times? Twice, right? It could go through here. We're going to deal with that in the next section. Those are going to be called chords, the piece between here and here, but we're not talking about that today. We're only worrying about a line that intersects it at one place. Or what else could a line do? Could it? Because it's a line. Can a line bend? So it can touch it one time, it can touch it 2 times, or it could never touch it if we had a line, as long as they're on the same plane, right? These guys never ever intersect. Does that make sense? Okay. So that is what we're dealing with today. And here is the fact that you need to know about a tangent line. A tangent line and the radius. Well, where's the radius? How will I know it's a radius? Where's the radius at? So from point A, I know that's point A. Right? I know that's the center because I named it that. So point C, that would be a radii. Radius, yes? Here's the fact you need to know. A line that is tangent to the circle and the radius where that goes through that point, those intersect at a 90-degree angle. The line that's tangent and the radius that goes through that point. This is called the point of tangency. That line is called, or that point is called the point of tangency. Because what does this have to add up to? 180. So yes, it would be tangent. It would be 90 degrees on both sides. So here's the fact you need to know. And this is the way you could do this. If I give you a circle and I tell you this line is tangent to the circle, what can you tell me about the angle that's formed right there? It's guaranteed got to be 90. So I told you it was tangent. You then could tell me that this angle was 90 degrees. The converse is also true. What does that mean? I give you a circle. I give you a line. I tell you that this is 90 degrees. What can you tell me about this line? It's a tangent line. That is called the converse. Yes, sir.
Converse ever not true?
Yes. For sure. In math, like, if we said this, I want to make sure I do one that's going to work out for you. So if the only time that you can do a converse is if and only if then statements. If and only this is true. Like, if a dog is a Dalmatian, right? Or if my pet is a dog or a Dalmatian, then my pet is a dog. Is the converse true? If my pet is a dog, then it's a Dalmatian. No, because I could have a different type of dog, right? So it depends on that kind of thing. So like, if a parallelogram, right, has, I guess this one would be true, but if a parallelogram was a square, then you know what I'm saying? Like it doesn't always, if it doesn't, if you can't switch it and makes it fact. And if the shape is a, then it's a square. Is that true? So when you switch it around, it depends on the if and then statements. I'll get you a better one. But it's not always true as a converse. But for the most part, they are. A lot of them are. Alright? So the converse is true in this case. So here we go. Now, what I want you to do today's big idea is I want you to start unboxing geometry and honestly unboxing math. That means anything that you've ever learned, I want you to really start trying to activate it. In fact, at the end of the class, I'm going to put up a question, and I'm just going to ask you to name me facts. Just tell me things that you know. I'm not even going to ask you a question. I just want you to give me facts, because that will help you with solving questions. When I put up questions, you should start going, okay, what do I know to be true? I know this, I know this, I know this. And then you take those facts and see if any of those facts help you solve your problem. You'll see what I mean hopefully here in just a second. So here we go. We got a circle. All right, and in this circle, we know that this is 6, and we'll call this circle P. We will call this point that hits out here J. We will call this K. We will call this M. If I tell you KJ, that line segment, is 9. KM, line segment, is 4. Is KJ a tangent line? I am asking that question. I am not telling you that to be true. I am asking, is it a tangent line? So let's start looking at the facts. Let's start laying out things that we know to be true. Okay? Where is K to J? Well, that would be this length, correct? And what did they tell us about that length? Does everybody understand that? Yes or no? Okay? We know Km, which is from here to here, is what? 4. What other fact do we know? I didn't say it over here. I didn't say it over here. What? JP is 6. Yep. No, we don't know that to be true. We don't know that to be true. We're trying to see, is it 90? Because if it is 90, then it's a tangent. The radius is 6? No. Yes, we do. She just said it.
Oh, it'd be 6.
Correct. I do this on purpose, right? Because this is what we like to do. We like to use our what? Our eyes, and we go, M looks to be about the midpoint, doesn't it? So then we say, if this is 4, then this has to be 4. Is that true? No. What do we know? We know if it goes from the center to the outside, it's a radius. And since we know this is 6, we know this has to be 6. Do you understand? And what does that mean the length of K to P has to be then? That is called the segment addition postulate that allows us to do that. Way back in like chapter 2. Maybe chapter 1, you're right. Now, if this line is going to be tangent, let's assume that it's true. Let's assume that it's true. If that line is tangent, what would that mean?
That line KJ, line KP, line KQ.
Close.
Did I agree with you?
Yes.
I just said
You said you forgot one thing.
what
The squares.
I know, but that's what I meant.
Okay.
You just automatically
So,
say
this right here, if this is going to be a tangent line, that's going to be a 90-degree angle, correct? If that's a 90-degree angle, then this has to be a right triangle. Yes? If that's a right triangle, then a squared plus b squared has to equal c squared. So 9 squared plus 6 squared would have to equal 10 squared. Why did I put a question mark above that equal sign? We don't know if this is a 90-degree angle. We're trying to kind of figure that out. Well, what happens if these two things, what if this plus this equals that? Then it has to be a 90-degree angle, right? What if it doesn't equal? Then it's not a 90-degree angle, which tells me that this is what? This line is what? Not a tangent line. Yes. It is not. Because when you do this, you get 81 plus 36. And I'm questioning, does that equal 100? And when I do this, I get 117 equals 100. No, it does not. Therefore, no, this line is not a tangent line. Does that make sense? Does everyone understand the thought process behind this? Pythagorean theorem, part of this chapter? Are you still able to use it? That's what I mean about unboxing. You guys are so used to, because, and especially in a lot of other classes, when you're in chapter 2 of like a history class, or maybe probably even science maybe has a little bit more recall, but for sure like history, what is the only thing that you're going to find on chapter 2 tests? The stuff that's in chapter 2. That's how math works. You have to use everything that's been taught to be able to do these things. That's why we have to teach them in a certain order, because we are going to use prior knowledge in all of these questions. Yes?
That's always not always true in history. That's like
Not
you
always.
really have to look deeper into like figures and all of this to figure out like.
For sure. It's not always true. But math definitely has that
To really
idea.
understand history, you have to like know the internet.
I agree for sure. But when we do testing here in school, most of the time chapter 2 stuff is just chapter 2. But I do agree, if you want to make anything better, start unboxing it and see how it all works together. How does all the history kind of tie together? Same with the math. All right, next question. You guys aren't even saying anything. Isn't that a pretty good circle? Oh, shut your mouse. You guys act like you control a better circle.
Just use the actual like circle in.
You know what, Brody?
You're gonna see which one's better if you're going to use the circle tool.
No. Go away. All right. So we've got this up here, and now I'm going to tell you some information. So this is S. This is T. We are calling this circle R. And I'm going to tell you the radius. X is the radius of circle R. We haven't gone over that, but that is the symbol for circle. You'll see a little dot with a circle around it. That is to represent that they're telling you they're talking about circle R. So X is the radius of circle R. They're going to put on the diagram that this is 24 and this is 18. They're also going to say that ST is tangent. It's a tangent line.
But we're gonna find more tangents.
So I'm telling you, I don't care how this looks. I don't know why it keeps drawing that. I don't care how this looks. This is the 90-degree angle. I don't care what it looks like. So what does that mean? I know I drew it terrible, but what does that mean? Is ST my hypotenuse? No, it is not. What is my hypotenuse? RT. We're going to talk about that in a second. What is the length of SR? X. They want me to solve for X, by the way. That's the question. Solve for X.
Fine, that's simple enough. We just do 24 plus x equals 18.
Why'd you put a question mark on that 18? You said it with your voice. You said a question mark. You know how we do that? You're like, equals 18? Wait, something doesn't seem right there. Because the hypotenuse is supposed to be the what?
Biggest.
The biggest. So from here to here, when they drew that diagram, they were trying to say this is 18. What is the length of this? X. What is the length of this whole thing? No, because 18x would be 18 times. But we're going to write it as x plus 18. That is the length of that RT side. Does everybody understand how I filled that in? Now, if that is true, and I'm telling you this is a 90-degree angle, I told you that when I told you the tangent, you do know that a squared plus b squared, like you were saying, Peyton, earlier, is got to equal c squared. Does that make sense? So that tells you that x squared plus 24 squared has to equal what?
X plus 18.
How do I write that? Because the way that you said that just says like this.
Now that we have to put it in parentheses, that's how it's
What is in parentheses?
18 plus 18. Sorry, x plus 18.
Thank you. Bless me. Thank you guys. I appreciate it. Yes.
You ever see that clip of Quentin Williams?
No.
Oh, you should.
All right. So this is what that means. Take a time out. I don't want you writing. I want you watching. Because I want to show you a common mistake. I teach Algebra 2. We do this all the time in Algebra 2. So I see the thought process. And I understand why kids make mistakes. So I'm bringing this to your attention so you don't make the same mistake. The thing that sucks about math, yes, I said it sucks, is that stuff looks the same. Things look similar, but the way we handle them is not the same. A quick example of that would be, how do you add fractions? What do they have to have? Common denominators. How do you multiply fractions? Top times top, and do those look similar? Guess what kids do all the time? Oh, they mix them up. And which one do you think they mix up the most? Yeah, because this one's pretty easy. So they get this question right, and they start applying the multiplication rules to the adding rules just because it was easy. Is that how we do things? Okay, so can you see how that would be a problem? So here's the mistake that I see oftentimes with this. Like I said, if you make this mistake, you are not alone. Do those things look similar? I think so. Do you see a 2? Do you see an X? Do you see an 18? Yeah. What do you do with this 2? You distribute it, which then gets you 2x plus 36. What do you think kids then do with this one? They distribute it, and that is wrong. Because if you distribute it, you would get x squared plus 18 squared, which is not the right answer. What does it mean when you square something?
It's just it's found itself.
So wouldn't that mean that you would have x plus 18 times x plus 18? Do you see how I talk to you? I try to say, what does it mean to square something? And I'm asking you to think, like, take a second and think, oh, it means times it by itself. Literally, what did I do then? I times it by itself. Now, how do you solve this problem? X times x is what? X times 18 is, hold on to that for a second, because this times this is another 18x, and those are common terms. Those are like terms, which means I can actually add those together. 18x plus 18x is, and then finally 18 times 18.
36x squared.
No, because you're adding 18 x's and another 18 x's.
If you have one x and another x, it'd be x squared.
When you multiply them, x times x is x squared. But what if I had 5 apples over here and I had 4 apples over here? When I put them together, how many do I have? 9 apples. They didn't become apples squared. You're literally, when you add, you are counting how many you have. You have 18 x's here. You have 18 more x's here. You have a total of 36 x's. And then 18 times 18 is 324. What does that mean I can do over here? What's 24 squared? That's 576. And this, I can take this out, gone, and what can I put in its place? Because you need to start understanding the concept that in math, we don't change values, we change the way things, this right here and this right here are the same. They are different forms, just like ice and water. It's just a different form. Sometimes I want water, sometimes I want ice. So I took this out because I did not want this written like this, and I put this in its place. Does that make sense? I know, Peyton, I'm just giving a kind of example. What? Yes, you can have steam, I guess. Vapor. Does this make sense? Yes or no? Now, what's my goal of algebra? You don't actually have to factor this one. I'll show you why. Sometimes these you would have to factor. The goal is to get x by its. The first way I want to try is always called isolation. That means you are getting the x alone. Does that make sense? How am I going to get the x alone? Get everything away from it. Well, can I minus x squared here? Yeah. It's an x squared, and what happens when I minus x squared? What do those do to each other? But if I minus x squared on one side, what do I have to do to be fair? And what happens, Owen, when I do that? The x squared is what? So there's no x squareds for me to have to factor and worry about that process, which can happen, but in this case it didn't, which is very nice. I like that. When I saw the x squared and the x squared, I was like, thank you, because I do not have to solve. If I can't get the x's by itself, then I have to do what Owen was saying, which is solve by factoring.
That's fun factoring though. That's the when you see what adds together.
Yeah. Yep. We'll talk about that after the EOC. I'll go into that more. So we're going to minus 324 because the idea is we're trying to get the x's all alone. So minus 324. And when I do that, I get 352. And that equals 36x divided by 36 divided by 36. And I get 7, I think.
Minusing 324.
Yeah. 352. 6 minus 4 is 2. 7 minus that is 5. 5 minus 2 is 3.
Isn't it 324, not 224?
Oh, is it 324? So this should be 252. Good. And then when I divide, is it 7? Is that the answer? So that's my x. There's my answer. So that would mean that 7 squared plus 24 squared should equal what? No. 7 squared plus 24 squared should equal 25 squared. Does that make sense? Because the x was 7 plus 18 is, this whole length is then 25. Alright, here's the point that I told you. I'm not going to ask you a question. I just want you to start giving me facts. 4th period crushed it on this one. That's a pretty good circle.
That dot in the middle though is not.
That's close. That's not terrible.
This is like where you drew the circle right and then you just along it. Ooh, it's a kite.
No, you don't actually have to write this one down. All right. Tell me some information that you know about this. Nope. You can't tell it's a kite yet. You got to give me way more information before you can just go and say something's a kite. Yeah.
E is a right angle, and angle B is a right.
Okay. Can we name it a little better than that?
Angle CDA.
Good. Angle CDA is a right angle.
Angle CBA is a right.
Perfect. That's great. Keep going. Just facts. I mean, it can be as simple. CB and CD are equal because they are both what? They're both a radius. Yes, or radii. The circle name is C. That's a fact. Absolutely. David, what you got? BA is a tangent line. Very good. Brody, what do you got? AD is a tangent line. Keep going. Peyton, what's up?
Let me see. So that wait, if there's 2,
All right. Keep thinking about it. I'll come back to you. Yes, bro.
DC is the radius.
Yeah, we said that.
Well, you did.
Mm-hmm.
BC is also a
We
radius.
said that, but we haven't said something about those two segments because they're both a radius, which is what? You know that CD, the line segment, is equal to CB because they're both a radius. Yes? What else?
AC. Sorry. What's that line there? Line AC.
Yes, it is line AC.
It's. I guess it bisects DCB.
Okay. We're going to worry about that. What do we know about that? Let's talk about AC for a second. What is it on triangle ABC?
It's a hypotenuse.
It's the hypotenuse. What is AC on ACD? It is the hypotenuse, yes? AC is equal to AC. Why? What is that called? It's called reflexive. Have I given you any question? But we're just spitting out facts. And if I gave you a question, one of those facts might be something that helps you solve the question. That's the way I need you to start to think in geometry. What are the things I know? I don't care how silly you think it is. Even if it's just, I know the name of the circle is C. Start off by doing that. Start giving yourself facts because the facts are going to be the reasons for why you can solve the questions. There's one more fact up here that we can keep proving. You guys have told me, let's label it, and hopefully it will come to your brain. You guys told me this length is equal to this length. You told me this length is the same as itself because it's a reflective property. What kind of triangles are those? They're right triangles. Therefore, how come I can tell you those two triangles have to be congruent to each other?
Angle.
Nope.
Wait,
Angle,
side,
angle
side,
is never. Nope. Side, side, nope. I only have two sides.
side. Angle says that. Wait.
I haven't said anything
side,
about
side.
angles yet. I haven't said anything about angles.
Yeah, you have. You
Nope.
have 90 degrees.
Oh, there it is. That's the one I was looking for. What kind of triangles are these? Right triangle. There is one similarity or congruency statement that only works for right triangles. It is called the HL, which says if you know the hypotenuse and you know one leg, that's all you need to do to say these two triangles are the same. Now, once we use the HL, now, Brody, we can start going, I know this length has to be the same as that. Why? C, P, C, T, C. Remember that thing? Corresponding parts of congruent triangles are congruent. I know
Why do you
this
know that?
angle has to be congruent to this angle. This angle has to be congruent to that angle. All by C, P, C, T, C. All these are just facts that we just laid out. And then we might look at the question, which I haven't even given to you yet, and say, how can I use those facts to help solve this question? But we don't go, this is 20. What's the measurement of x? We don't just go, oh, it's just 20. Why? Because I see a 20, and so I'm guessing it's 20. That's not what we do. We have to label facts and say, this is what I know to be true, because this is true, this is true. If this is true, then this is true. And if this is true, x is 20. You have to lay it out like it's a lawyer, and you are saying, I know for a fact. It's not, well, just because there was a 20 up there, I just called it 20 and said, we're good. Does that make sense? Start thinking like this. Give me facts. Label it out. All right, so here we go. Next question. I'm going to give you a minute to try this one. That's a terrible circle. That's, excuse me. I don't make fun of y'all
Just redraw it.
to your face.
Excuse me, Mr. Martin. Line AC isn't really touching the circle.
It's okay.
Mr. Martin, I know you told us not to assume in math, but I'm just gonna have to assume that you're definitely not an artist.
No, I'm not.
Okay.
I've excluded that. Hopefully you're going to start to see, again with this question, and hopefully your eyes are continuing to be open every day as you come in here to understanding this idea or concept, that you have to just use everything that you know. And that's why we did that last question. We just started labeling like, okay, what do I know? What do I know? What do I know? And you start pulling that to the forefront of your brain, and you say, is that going to help me? Yes or no? Throw it out or keep it. Is this going to help me? Throw it out or keep it. So again, we're keeping with that idea. What do we know? When they say line in and line in are tangent, what does that tell me? I go right here and I go, okay, that means where this intersects has to be 90 degrees. Where this intersects, that has to be 90 degrees. I know that to be true. Okay? What other information did they say to me? What? BC what? This means something. It's not, because there could be a line segment. What is that symbol? Arc. Arc. BC is 135. That means the measure of this is 135 degrees. What does that tell me? Angle BTC is also 135 because we know the central angle that forms this arc is the same measurement as the arc. So if they tell me the arc is 135, the angle that makes it is also 135. If I tell you the angle is 135, you know the arc is also 135. We did practice on that a couple nights ago. Yes or no? What kind of shape is made? Don't go too specific yet. What kind of shape do we know this to be? Because we don't really need the specific one to help us solve this. A quadrilateral. Do we know what all quadrilaterals, the interior angles, have to add up to? How did you get that? Yes, keep going, Peyton. N minus 2 times 180 tells me what all polygons, no matter how many sides it has, how much all the interior angles add up to. What is my n in this case? 4. 4 minus 2 is, so does everyone understand how I got 2? That was a 4. 4 minus 2 is 2. 2 times 180 is 360. That means this angle plus this angle plus this angle plus this angle all have to add up to. So I'm going to go 360 is equal to 90 plus 135 plus 90 plus x. 360 equals, add these together, what did you get? 315 plus x. Now what do I do to get the x by itself? Minus the 315, and I get 45 equals x. There is my answer.
That's so complicated.
That is how they're going to start getting.
You just turn into 2 right triangles. You know,
Yeah, I wouldn't do that. I would do this one. It would work, but you'd have to double it at the end. Does this make sense about geometry? Start unboxing it. That's from old.